All right, so today is the day 2 of our parametric equations. So you'll see that we're not really graphing today, but today we're going to kind of analyze a little bit more within them, looking a little bit into some physics type stuff. If you've had any kind of physics classes or anything, you'll see maybe that this ties into it a little bit. Really just thinking again about the different X movement and the different Y movement. That's what the parametric does, is it kind of separates them. So let's look at the first one here. From its initial position at 3, 4, so it's giving us a starting point, an object moves linearly, so we know it's a line, reaching 9, 8 after 2 seconds and 15, 12 after 4 seconds. So let's think about it here. We want to predict the object after 6 seconds, 9 seconds, and t seconds, okay? So if we are starting off at 3, 4, and then after 2 seconds, it gets to 9, 8. So we really are just trying to think through a pattern. If I go look at my x's, so from 3 to 9 in 2 seconds, it goes up 6, right? Actually, I should say, I'm sorry, it goes to the right 6. Since it's an x coordinate there, it moves to the right 6. And then if we think about from 9 to 15, again, it's another 2 seconds later. So 2 seconds it takes to go 6 to the right to get to 9. And then another 2 seconds, notice it goes another 6 to the right. So if we want 6 seconds, this one's pretty easy because that's just 2 seconds after. So this was 2 seconds at 4 seconds. So 6 seconds is just 6, it's going to be 6 away from that. So that means my x coordinate is just the 15 and 6 to the right of that. My x coordinate's going to be 21. All right, if we think about the y coordinates within here. So if I go from 4 to 9 after 2 seconds, I'm sorry, 4 to 8 after 2 seconds, that moves it up 4. So that's our y coordinate, so we're going up 4. And then going from 8 to 12 after 4 seconds, so that's another 2 seconds later. Notice again that's going up 4. So that means after 6 seconds, it's going to go an additional 4 units up. So that means the 12 plus 4 is going to give us that y coordinate of 16. Now 9 seconds, that one's maybe a little bit harder to think about here. Not impossible at all, but we just have to kind of think a little bit carefully. So we could easily do 8 seconds, right? Now this is just one way to do it. Like if I were to do 8 seconds, we know it would be, again, just 2 seconds after the 6. So an additional 6 seconds, 6 units to the right there. So that would be at 27, an additional 4 units up at 20. So we know that at t equals 8, it would be that. So t equals 9, that's the odd number though. It's not going every 2 seconds. So we really need to think about this in linear terms. So if it goes 6 units to the right after 2 seconds, that means it would be 3 units to the right after 1 second. So to get to the 9 seconds, if we're going 3 units to the right, that x coordinate's going to be 30. And then if we look at the y coordinates, it's going up 4 every 2 seconds. That means it'd be going up 2 every 1 second. So 1 second after the 8, that would be going up 2. Our y coordinate would be 22. Again, different ways to do that. That's just one option that we have there. But now we want to think about after t seconds. So really here, we're coming up with our x and our y. This is really coming up with our parametric equations here. So we have to kind of think about it, and we sort of talked about it here. We said it would go every 1 second, it goes 3 to the right, and then every 1 second, it goes 2 up. So if it goes 3 to the right every 1 second, that's really 3t. If it goes 2 up every 1 second, that's 2t for the y coordinate. So to the left and right for the x, up and down for the y, and here it goes to the right and up. Now we have to think about, this is not it though, because it does give us our initial position. And really the initial position is when t equals 0. So if t were equal to 0 here, we would need that initial position to be the x coordinate of 3. And then if our initial position again at t equals 0 is the y coordinate is 4, this is going to be then our parametric equations for this here. Okay, so let's kind of think about the next part here. Is there a time when the object is equidistant from the coordinate axes? If so, when? Think about if something is equidistant, that means it has the same distance. So if I were, at a point here, this distance and this distance, we would want them to be the same. Well, the horizontal distance is your x coordinate and your vertical distance is your y coordinate. So really what we're saying is we want to know, when does x and y equal each other? Is there a time when x and y equal each other? So I can just take my parametric equations that we just came up with. So 3t plus 3. When does that equal 2t plus 4? Solve the equation, subtract 2t, subtract the 3 at t equals 1. So they are equal distance. I'm going to say yes after 1 second. So after 1 second, they would be equidistant from the axes. So you can think about where it would be after that. So x would be 6 units away and y would be 6 units away if you were to just plug them back into our equations there. All right, so let's try another one here. This time I'm giving you the parametric equations. So we have two parametric equations and we want to describe the movement of the particle in meters per second. How does a particle's position change each second and each minute, and what is the speed here? And then we're going to come up with our rectangular equation. So go back and think about this one. So again, if we were thinking through these, here we talked about it moving to the right 3 every 1 second. Here it moved up 2 every 1 second. Think about how that related to our equations. So let's start off though kind of basics. Let's come up with some points here. If t were 0, what would our ordered pair be? So if t were 0, if I were to plug it into my x and my y right here, my x coordinate would be -2, my y coordinate would be 6. Let's come up with a few more just to see if we can come up with any patterns here. If t is 1, we would get an x coordinate of -5 and a y coordinate of 10. If t were equal to, let's go 2, we would get an x coordinate of -8 and a y coordinate of 14. Okay, you get the idea. Notice what's happening. If there's a pattern here that's forming along the way here. So for my x's, notice each time it's actually going to the left 3 every second. Kind of think about that. Again, if it starts at time equals 0, -2, and then it goes left 3 after another second and left 3 after another second to get to -8. If we look at the y coordinate, those are increasing. It would be going up 4 every 1 second. And that's really what we're coming up with here. So the particle travels, I'm going to say particle travels, just kind of get it a nice sentence here. 3, we could say units to the left. This is in meters per second, so it's going to be meters left every second. And then it would be going up 4 meters every second. Okay, so that's what we're kind of thinking about. So now we also want to do that in each minute on this one here. So if we're thinking in each minute, I'll say and on this. So if that was every second, we know that there's 60 seconds to every minute. That means if I take the 3 meters and I multiply times 60, that means it's going to be 180 units or meters left. And we are doing 4 times the 60, that would be 240 units or meters up every minute. Okay, so now we want to think about our speed here. So we're thinking through the speed on this. When we think of our speed, let's kind of draw ourselves a little picture here. So if you think about it, this is going to the left 3, and then it's also going up 4. Okay, if we're looking at this, really, this is the actual path. If I draw it in a different color, let's use blue here. The path that the particle is actually traveling is along this blue. So that's really what we're trying to think about. So every second, it's going to go whatever this distance actually is here. So if you notice, this is a right triangle. 3 squared plus 4 squared would equal 5 squared. So that actually means its speed is 5 meters per second. on this. So that's how we can come up with our speed. Now we want to think through a rectangular form of the equation on this one. So we think of a rectangular form. Sorry, I'm getting kind of sloppy and running out of room on this one here. I'm writing too much. So it's really what we had done the other day. We can think through, solve one of the equations for t and then put it into the other one. I'm going to solve the x equation just so if when I put it back in I get a y equals. So if I solve my x equation, take this, solve my x equation for t, that means I'm going to add 2, oops, that would be negative 3t, sorry, and then that would give me t is x plus 2, oops, positive x plus 2. X plus 2 divided by that negative 3. If I put that into my y equation, so it's 6 plus 4 times the x plus 2 over negative 3. Now this equation would be fine. I mean, that would be okay. But really, let's see if we can come up with a slope, like a slope-intercept form, so we can look at our slope. So if I were to multiply this out, I'm going to look at the parentheses here. We would do 4 times the x divided by negative 3. That would give us a slope of negative 4/3 with the x. If I distribute the 4, we're multiplying it times 2 over negative 3. That would give us negative 8/3. And then 6 plus negative 8/3, that would be 18/3 minus 8/3. I would get a plus 10/3. So this is actually our slope-intercept form of it right here. Okay, so what I want you to do, I actually want you to pause this for a minute right now, and I want to see if you can come up with this next equation based off of what we just did. See if you can think about what the slope is. Use those last couple examples on here and see if you can think about what our slope might be. And I'll come back and kind of talk through my answer key on here. All right, so hopefully maybe you tried this one on your own. Really all I did was come up with an equation of the line, what we had done the other day. So I solved my x equation for t, and that's a 3 right there. Put that into the y equation so we could get a rectangular equation. And once I did that, I saw that really this is my rectangular equation. Again, I distributed the 2 forward. This is really x over 3 plus 4 over 3. If we were to distribute the 2 into there, we get 2/3 x plus 11/3. So we can easily see that the slope is 2/3. Think about how this relates to our equations. Go back and look at the one that we had just done as well. If you think about it, we know slope is the change in y over the change in x. If you look at this, go back and look at this equation. If you look at the coefficient of the t on the y equation and the coefficient of the t on the x equation, notice that's really what our slope ends up being. Go back and look up at number 2. Again, notice the coefficient of the t on the y equation and the coefficient on the t of the x equation there. So that's really what we're thinking about here. This is the coefficient of the t on the x equals equation. I'm sorry, the y equals, whoa, okay, it's always y over x, sorry. And this one is the coefficient of the t on the x equals equation. I'm struggling to write here. And that's really what we can kind of come up with here. So again, use that. Try number 4 and number 5 on this one here. I'm going to tell you that you can actually have multiple ways to answer this then. So see if you can think about this one, and I'll come back. I'll unpause my video then too to come back and talk about it. All right, so I have one example. I'm going to tell you again, this is not the only example. We'll talk about this here and why and what some other possible examples that we have. What I thought of is, again, if we're thinking through this as a particle here, and let's say this is the initial position. Now, do we necessarily know which is our initial position? No, we don't know what time is 0 on this one here. But let's say it is. So to get from 5 to 7, notice we would go to the right 2. So I made the coefficient on the x coordinate here, I'm sorry, of the t on the x equals graph, my goodness. Notice would be 2 to the right there. And then if I go from negative 3 to 1 for the y's, I would be going up 4, and that gave me the 4 in front of the t on the y equation. Now, the 5 and the negative 3 came from if I called this point A, if I called that at time 0. So if time was 0, 2 times 0 plus 5 would give me the x position of 5, and 4 times 0 minus 3 would give me the y position of negative 3. Again, there are other possible answers. Did we know that it necessarily started at 5, negative 3? No, we did not. So we could use even the same coefficients here, but I could have said that maybe point B was the initial position, so that would be a plus 7 and a plus 1. Now, again, you have other options on this here. You could have, do we necessarily know that it is moving in that positive direction? No, I could have done negative 2t, but that would have mean that this was negative 4t. Again, if you think about that coefficient on the t on the y equation and the coefficient of the t on the x equation, if you do the change in y over change in x really to think about our slope, that would still give you that same slope that we would have otherwise. So that would work, and again, you could use either the 5 or the 5 and negative 3 or the 7 and the 1 on there. Again, that's another option for you. You could keep going. Again, you could adjust some other things. What if you doubled it here? You could have 4t and this be 8t. And again, start at either position, the 5 and the negative 3 or 7 and 1. Or again, I'm getting a little crazy showing all of them on here. You could have done a 1t and a 2t, and again picked either point. Let's do a plus 7 and a plus 1 on that one. Again, really what you're doing on this is you're changing the speed. It has the same path. Okay, it would be the same if you were to go continuously from like negative infinity to positive infinity for t. It would be the same line. But if you, it depends on your starting point, and it depends on which direction that you're going and what speed you're going at. So that's a really big thing to think about. It really is changing our speed. Same path, different speed. So try the next one. Again, come back and see if you got it. All right, I wrote down a few of my examples here. Again, if you think about our slope, this is the change in y over change in x, so that can tell us the coefficients of the t term in both the x and the y equation. Now, it would be your choice of which one you wanted to do the negative. So if you look at both of these, I just switched which the negatives were, right? I could make that the x a positive 4 and the y a negative 3, or the x a negative 4 and the y a positive 3. Now think about where I got the 6 from. Okay, I didn't tell you any points on here, but if we look at this line, we know that it has a y-intercept of 0, 6. So we could say, what if that's our initial position then? So that could be our starting. So the x is 4t really plus 0, and then the y is the negative 3t plus 6. Now, is that the only point we could pick? No. Take a minute and think about where I got these numbers here. Really, I just picked another point on here. I used 4 to make a nice easy denominator, so I didn't have to mess with the fractions. If we plug in 4 to our y equals negative 3/4 x plus 6, we would get a y coordinate of 3, and that could be another starting point on there. So I want you to try some of these. Again, there's multiple answers within a lot of them, but make sure that it does work with your equations. On my answer keys, I'll try and show a bunch of different answers. All right, let me know if there are questions. Bye, guys.